Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, the operating cost C in dollars per hour for an airplane cruising at a height of h meters and an airspeed of 200 kilometers per hour is given by C equals 4000 plus h over 15 plus 15 million over h for the domain that h is between 1000 and 20,000. And we have to determine the height at which the operating cost is at a minimum and find the operating cost per hour at this height. So in this problem, we have to find the height at which the C value is a minimum. Now we know that the C value will be at a minimum at point where the tangent is horizontal, because at those points the C function will form valleys in the graph. So the first step is to find the derivative of the C function and then set it equal to 0, because the derivative represents the slope of the tangent to this function. Now in order to find the derivative of this function, we should move the h term that's in the denominator to the numerator, because that will make finding the derivative easier. So the first step is, so we'll rewrite the cost function. So C equals 4000 plus h over 15 and then plus 15 million times h exponent -1. Now we can find the derivative of this function. So this function has three terms, so we'll have to find the derivative of each term. So C prime is equal to, so 4000 is a constant, so its derivative is 0. Now in this second term, the 15 in the denominator is part of the coefficient 1 over 15. So that means the derivative of h over 15 will be just 1 over 15, because the coefficient of h in the numerator is 1. Now for the last term, so the 15 million is the coefficient, so it will stay as it is. And for h exponent -1, we'll use the power rule. So as per the power rule, the -1 will come to the front and will subtract 1 from the exponent. Now we can simplify this expression. So C prime equals, so 0 goes away, so we get 1 over 15 and then minus 15 million and then h exponent -2. Now we have to find the h values at which the derivative is equal to 0. So we'll set C prime equal to 0 and we have to solve for h. Now in the second term, we can move the h to the denominator to make the exponent positive. Over h squared. Now we can isolate h by moving this second term 15 million over h squared to the left side of this equation, and if we do that, this term will become positive. So we get 15 million over h squared equals 1 over 15. Now we can move h squared to the numerator by cross multiplying the denominator on both sides. So that way we'll be able to isolate h on the right side of this equation. So our step will be, so 15 million times 15 equals h squared. Now we can multiply the numbers on the left side. So we get 225 million equals h squared. And now we can apply square root to both sides. So on the right side, the square root and the square cancel each other out, and square root of 225 million is 15,000. So that means h is equal to 15,000 and the unit is meters, because that's the given unit for height. Now this h value lies in the given domain between 1000 and 20,000. So this is a valid value of h for our analysis. Now we have to find the height at which the operating cost is at a minimum. So we'll calculate the operating cost at three heights at h equals 1000, which is the lower limit of the given domain, and then 15,000 meters, the value we just found, and then 20,000 meters, the upper limit of the domain. So let's start with c at 1000. So I can use a different color. So for c at 1000, so we'll sub in h as 1000 in the c function. So it's 4000 plus 1000 over 15, and then plus 15 million over 1000. Now we can simplify this expression. So c at 1000 equals, so 4000 plus, so 1000 over 15 is equal to 66.67, and then plus 15,000. So now we can combine these terms. So when we add these numbers, we get the 19,066.67, and the unit is dollars per hour, because that's the given unit of C. So next we have to calculate the cost for H equals 15,000. So our expression will be C at 15,000 equals, so we sub in H as 15,000 in the cost function, so 4,000 plus 15,000 over 15, and then plus 15 million over 15,000. Now we can simplify this expression. So C at 15,000 is equal to 4,000 plus 1,000 plus another 1,000. So we get C at 15,000 equals 6,000, and the unit will be dollars per hour. Now we can calculate the C value for H equals 20,000. So we get 4,000 plus and 20,000 over 15 plus 15 million over 20,000. So I got C at 20,000 equals, so 4,000 and then plus, so 20,000 divided by 15 is 1,333.33, and then plus 15 million divided by 20,000, which is equal to 750. And now we can add these three numbers. So we get 4,000 plus 1,333.33 plus 750. So I got 6083.33, and the unit will be dollars per hour. Now we have to find the height at which the operating cost is at a minimum, and we got the lowest operating cost of $6,000 for the h of 15,000 meters. So our final answer will be, so the height at which the operating cost is minimum is 15,000 meters, and the minimum operating cost in the given domain is $6,000 per hour. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to first understand that we have to find the derivative of this cost function to find the h values at which the tangent is horizontal, because for minimum cost we have to find the h value at points where valleys are formed in the graph of the c function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.